right, this is Analyzing a Graph, Unit 3, Lesson 12. First, let's look at linear functions. How do you know this graph represents a linear function? Because it consists of a straight line and there is a constant rate of change. Is this graph the parent function for the linear function family? Well, I can tell you no because it doesn't cross through the origin. But they have more information. No, the parent function y equals x has a slope of 1. This does not. If you look here, it rises 2 and runs 1, so it has a slope of 2. And it has a y-intercept of 0. So there's two reasons this is not the parent function. This graph shows the parent function, y equals x. The function on the left is a transformed linear function. So this is a transformed function of the formula y equals x, or f of x equals x. Okay, this one has been transformed to create this. The changes to the parent function are, so what happened to this one to make it look like this? The new function has a steeper slope. You can see it's been tilted up, okay? It has a steeper slope. This slope is 1, rise 1, run 1. This one is 2, okay? The slope of the new function is 2. The new function has a different y-intercept. So this intercepts y at 0, this one intercepts at 1. Okay. The changes to the parent function are the new function has a different x-intercept. So on the parent function, it intercepts x at 0. Here it intercepts x at, let's blow it up because I have old lady eyes, looks like about 1/2, okay. The x-intercept of the parent function is 0, 0. The x-intercept of the new function is -1/2, 0. I was right for once. Oh my gosh, I have to revel anytime that I'm smart. What transformations could have created the new function? So changing the slope of the original function could be caused by a vertical dilation. This graph would have been dilated by a factor of 2. Changing the y-intercept of the original function could have been caused by a vertical translation up 1 unit. So they're saying they dilated it by a factor of 2, and then they translated it up 1 unit to make it cross through that y-intercept of 1. Combining both of the previous transformations would account for the change in the x-intercept. So it would take care of everything that happened to those two transformations. Here's a check-in. What key features of a graph will help identify transformations from a parent function? So basically, what do we look at to try to figure out what transformations happened? What you need to look at is the slope, if the function is linear, x-intercepts. Okay, so it's only if the functions are linear that the slope is of value, okay? The slope doesn't really matter for the other stuff. Sorry, I forgot to close that. So we're looking at slope, x-intercepts, y-intercepts, and how narrow or wide the graph is. Look at that. I did not put that behind. Okay, now you can actually read all of that. So it does ask questions about this later on in the lesson, so you might want to write this down. But I don't recall it being in the quick check. It may be, you know, I'm a hot mess. Quadratic functions. How do you know the graph represents a quadratic function? Because it has a parabolic shape or a U-shaped curve. Is the graph the parent function for the linear family? Okay, the linear function family. It does touch the origin at 0, 0, but the parent function opens up. It should look like this. It's also wider. You can see this is a lot narrower. The graph of the parent function is a parabola that opens upwards. The new function is a transformed quadratic equation. We know quadratic function. I can do this. We can tell that this has been changed from this. Okay. The changes to the parent function are as follows. The parent function opens upward while the transformed function opens downward. So the first thing they did was flip it upside down. The new function appears narrower than the parent function. The y-coordinates in the new function have all been multiplied by 2. So if you look here, we have like -1, 1. It got changed to -1, 2. So the y-coordinate changed. It got multiplied by 2. -2, 8 became -2, 4 became -2, 8. So they're looking at these numbers and going, okay, well, if I multiply this one by 2, I get this point. Scream sneezer. I cover the microphone for you. You're welcome. If we look at this point, say 2, 4, we know if we multiply 4 by 2, we're going to get 8. okay? So all of these numbers are getting multiplied. Now the fact that it's positive and negative is because it's been flipped upside down, so don't let that upset you too much. Graphs have an x-intercept at the origin. Both graphs have the same y-intercept at the origin. So we looked at all four things that it was telling us back here we needed to look at. Slope doesn't matter because it's not linear, but x-intercept, y-intercept, and how narrow or wide the graph is. Okay. The changes to the parent function are as follows. That's the one we just did. We need the transformations now. What transformations could have created the new function? A reflection over the x-axis would have caused the differences in the direction the parabola opens. A vertical stretch by a factor of 2 would multiply all the y values by 2. The first two transformations would not change the x-intercepts of the parent function. The first two transformations would not change the y-intercept of the parent function. So we know that we only needed those two things because there's no other changes that we need to account for. Now, if you're wondering how we would know that the vertical stretch is by a factor of 2 and all of this nonsense, you need to go back to that chart that I made that you should have printed or saved from the last lesson. You can figure out, okay, if the y value is changing, that means that the k is in the y value, and we know it's either stretching or compressing, so you know it's a dilation. And so then you can go there and you can figure out, okay, so where is the 2 going to fall? And that the chart will help you, okay? We'll get there as we go along. Absolute value functions. How do you know the graph represents an absolute value function? Because it consists of a v-shaped function with constant opposite slopes on both sides of the vertex. Does the graph represent the parent function in the absolute value function family? No. We know that immediately because it's not touching the origin. The parent function is a v-shaped function with a vertex at 0, 0. So here we have the translated function, not translated, sorry, the transformed function and the parent function, okay? The new function is a transformed absolute value function. The change from the parent function to the new function is that the vertex moved from 0, 0 over here to negative 2, 0. So what transformations could have created the new function? Well, we know if we're shifting that that's a translation, okay? And that because we're going side to side, it's a horizontal translation. So a horizontal shift could have created the new function. Now this is important. These are all of the parent functions. You need this. Take a picture, print it, whatever you need to do. You need this. You need to know where they sit on the origin, what their slopes are, what these standard points are, so that you can keep referring to this throughout the lesson so you know what the parent function is so you can figure out the translations. Okay? Here's a check-in. How can you determine what the parent function is for a transformed graph? So you determine the general shape of the graph. Is it linear, like a straight line? Is it a U-shaped function, which is a parabola, or is it a V-shaped function? Transformations do not change the general shape of a graph. They do not change its position and or the steepness of the curve. If it was a line, it's going to stay a line. If it's a parabola, it's going to stay a parabola. If it's V-shaped, it's going to stay V-shaped. It's not going to change that much. It's just going to move around. Okay, now there's interactive questions in the lesson, and there's a third one which made no sense to me whatsoever. So yeah, whatever, just skip it. It doesn't matter. You don't get graded. The first one says which two graphs are parent functions. So the easiest way to figure this is to get your chart that I told you to print or take a picture of or whatever and figure it out. This one right here is a parent function because it touches the origin right there. And now you have these two that you have to figure out is which one is the parent function because they both cross through the origin, okay? And the way you do that is you look at the slope. This is rise 1, run 1, so this is the parent origin. This one is rise 3, 1, run, so the slope is 3. So this one and this one are the correct graphs. All of these others have been transformed. Here's interactive question number 2. How should you compare the graph of a new linear function to the parent function? This question frustrates the crap out of me because there's more than one correct answer. For example, when you say look at where the line crosses the y-axis, that's the y-intercept, and you are supposed to look at that. Look at the equation and notice the differences. That's obviously wrong because we don't get equations in this entire lesson. You can look at the slope and the y-intercept. The slope is only correct if it's a linear function. They told us that earlier. Look at where the line crosses the x-axis. You need to look at that too. This question is a hot mess. But the most correct answer is to look at the slope and the y-intercept because you need to look at more than one thing. This is a waste. This is garbage. Here's question number 1. This is your turn, okay? Based on the key features of the graphed function, identify its type. What type of function is this? Figure it out. You can do this. The function is a quadratic function. It has the same U shape as the parent function. That's all it's asking you in this question, but it gives us more information. Y equals x squared is the formula, but all coordinates have been shifted 5 units to the left. You shouldn't be able to answer all of that yet. But you know, it wants to be difficult and make you cry. Here's question number 2. Oh, and look, I already gave you the answer. Whoopsie daisy. Based on the key features of the graphed function, identify its type. What type of function is that? Well, obviously it's linear because it's a line. The function is a linear function. It is a straight line like its parent function y equals x. That's all you should know. They throw in its slope of 2 could be due to either a vertical stretch or horizontal compression. You shouldn't. It didn't ask you for that information. Don't worry. Okay, here's example number 1. We're moving on to more. We're digging in deeper. Examine the graph to determine the parent function and the transformation from the parent function. This example involves functions with only one transformation. So the first thing it wants us to do is identify the parent function. Well, obviously that's a parabola, and if you look at your little cheat sheet, that means it's a quadratic parent function. Okay. The parent function of a parabola-shaped curve is a quadratic function with the equation y equals x squared. This graph has the same intercepts as the parent function because it's touching the origin, so it didn't shift up or down, okay? There was no translation going on. But it opens upward, so it didn't reflect across the x-axis, okay? But it appears to be wider than y equals x squared. And the reason we know that is if you look at your little chart, origin 0, 0, this should be negative 1, 1, and this should be 1, 1. But it's sitting at negative 2, 2, and positive 2, 2. Okay, so we know that there's some sort of dilation going on here, either a compression or stretching. So the next thing it does is it wants us to make tables of the information. So this table is just all of these points, okay? And this is really stupid that they want you to actually take the time to go through and make these tables, but this is like kindergarten stuff. Can you take this number and put it in a table? Well, yeah. Can you take that number and stick it there, that number and stick it there, that number and stick it there, that number and stick it there? Wow. Now can you go to your parent function chart paper cheat thing and do the exact same thing? Wow, you're so smart. So the parent graph on the chart that you have doesn't have the 4 and 4, but if it makes sense because if you have 2, 4, and 0, 0, then the next one is going to be 4, 16. So just, this is right. This is the parent function points, coordinate points, okay? So what number would you multiply the original y values by, these ones, to obtain the y values of the graphed function? Okay, so how do you go from this to this transformed function? So the way they laid it out was they did 16 is equal to k8. Okay, so 16 to 8, which is k is equal to 1/2. Okay, I just did that in my brain. It just made sense. In order to get from 16 to 8, you have to multiply it by 1/2 or divide by 2. Okay, so that's going to make your formula y equals 1/2 f of x, or for this specific formula, y equals 1/2 x squared. This x squared comes because it's a parabola. The original parent formula is y equals x squared. Okay, so because this has been shrunken, squeezed in, it's y equals 1/2 x squared. That's how they came up with that formula. We're going to do it again. Okay. Examine the graph to determine the parent function and the transformation from the parent function. This example involves functions with only one transformation. We only have to figure out one. Okay. If you look at that and refer to your chart, you'll see this is an absolute value parent. This is an absolute value function. Okay, because it's the V shape. The parent function of a v-shaped curve is an absolute value function with an equation of y equals the absolute value of x. Now on these little charts, I did not write down the equations for these, so you might want to write them down like that this is y equals the absolute value of x, unless you already know them. This graph has different intercepts as the parent function, okay? Because the parent function goes to the origin at 0, 0. This is over here at negative 1, 0. But it opens upward and appears to have the same steepness as the parent function. And we know we only have one transformation. So this one has been translated horizontally. Okay, we can tell that. It just got shifted over. Therefore, the new x-intercept helps illustrate the translation needed to shift the parent function to the graphed function. This graph has been moved to the left 1 unit. Now remember, when we're doing horizontal, it's the x-axis, it has to be contrary. So even though we're going to negative 1, we write it as a positive 1. It has to be the opposite. The graph has been moved to the left 1 unit. This would also change the y-intercept. Before, the y-intercept was 0, 0, and now it's 0, 1. Okay, so our formula is going to look like y equals f of x plus 1, or to get specific, because this is an absolute value function, it's y equals the absolute value of x plus 1. Here's the two charts if you're interested in that. This one refers to our transformed graph. This one refers to the parent graph. Here is example 3. Hopefully this is starting to click for you. Examine the graph to determine the parent function and the transformation from the parent function. This example involves functions with only one transformation. I just realized this like S-bend curve is not on my table of graphs. So I will go and fix that. I apologize for that so that it's on here. Add S-bend curve. Okay, so the parent function of this curve is a cubic function with the equation y equals x cubed. This graph has the same intercepts as the parent function because you can see it crossing through the origin right there. So it's not a translation, it didn't move side to side or up and down. And appears to have the same steepness, so it's not a dilation, but it's going in the opposite direction, okay? So remember, these ones are weird because when they're reflected, they look exactly the same. But this one started at the top and went to the bottom, and now it's starting at the bottom and going to the top. Okay, these ones are unique. You can see it better in the table. So this one started here and went down. This one started here and went up. Okay, it appears that all of the y values have been negated. Okay, so see how here we're at negative 8 and then negative 8 is down here. So negative 8 went to positive 8, negative 1 went to positive 1. That's what it's saying, which is caused by a reflection over the x-axis. It flipped upside down. Thus, the transformed function would be y equals negative f of x or y equals negative x cubed. And you can find these formulas by looking back at the chart from last lesson. Okay. Check in what key features of a graph illustrate the transformations that have occurred. The steepness or rate of change of the graph, the intercepts, and the direction a graph opens all help illustrate the transformations that have occurred. Example number 4. Use the image to think about how the graph of the parent function has been transformed. Okay, so the first thing is the function graphed is a transformed quadratic function. We know that because it's a parabola. From the parent function y equals x squared. We know that because y equals x squared is the parent function formula for a parabola. It appears to have been translated down 4 units. We can see that because it's not touching the origin. It's clear down here at 0, negative 4. In addition, we have more than one transformation now. The graph appears to have been vertically stretched as it seems narrower than a typical quadratic function. You can tell that because it should be over 1 up 1, but it's over 1 up 2 now. Okay, so it's been stretched. So here's our two charts. Okay, this one is the transformed one, this is the parent function. By following the order of operations, you can determine that this function will be written as y equals k of 1 of f of x plus at k2. Okay, we're going to stop for a minute, pause, and work our way through this. So this k of f of x. Okay, I'm writing this the way it's not on your chart. Let me write it the right way. So this is written on your chart from last week as kf of x. If you go and look this up, you can see that k times f of x is a vertical stretch, which we already determined from before. Okay? And then when we add k at the end, we have f of x plus or minus k, and you can see that that is a vertical translation, which makes sense because it's going up and down. Okay? So this is how we got this formula. This is the dilation, this is the translation. Since the transformed function has a y-intercept that has been moved down 4 units, the value of k2 is -4. This creates the equation y equals k1 of f of x minus 4 times f of x. I apologize. To solve for k1, or the vertical stretch, use the numbers in the table. Okay, so we figured it out because you can just go up 2 over 1, so we know that the slope is 2, but you're not always going to be able to do that. So what you would do is get the k value that you can determine, which in this case is k2, and plug it into your formula, okay? And then we're going to isolate k1. So the first thing we're going to do is simplify. So f of x we know is x squared because the parent function is y equals x squared. So that gives us y equals k1 times x squared minus 4. Okay. Now, what we need to do is figure out a value for x right here. We're just going to use the first one, which is -2. It doesn't matter which table you're looking at. It's -2 for both of them. Okay. So that gives us y equals k1 times -2 squared minus 4. PEMDAS says do parentheses first and then exponents. So -2 times -2 is +4. So that gives us y equals 4 times k1, that's this bit, minus 4. We're still trying to get k1 by itself, okay? So what we're going to do is we're going to, I don't know why this 4 just disappeared, but you would divide both sides. Oh, I guess let's see if I can figure this out. Y equals 4, I'm just going to put 1k because I'm bad at writing, minus 4. Let's add 4 and add 4. I think they just skipped a step. So that gives us y plus 4 is equal to 4k, because now we're going to divide by 4 to get k by itself. Divide by 4, and I'm out of room, so I'm coming up here, which is going to be y. See, that should be y plus 1 equals k. But they ended up with k equals 2. Well, we already knew what the slope was because it's rise 2, run 1. So whatever, people, you do you. Check in. To write the equation of a transformed function, what should you first identify about the graph? You should first identify the parent function so that you can begin to examine how the parent function has been translated. So step number 1 is always the parent function. Here's question 1. It's your turn. Create a table for the function represented in the graph, as well as a table for the parent function. Use -3, -2, -1, 0, 1, 2, and 3 for x. This is kindergarten junk. This is so dumb. Literally make a table with these points and then make a table with the points for the parent graph. Oh, look, you did it. Smarty pants. Okay. I'd literally -5 9s right there, -4 4s right there, -3 1s right there. This is like the stupidest question ever. Okay. And then it says, question 2, use the tables in the graph from question 1 of the to write the equation of the transformed function. And look at this. I gave you the answer already. Oopsie daisy. The transformed function has the same y values as the parent function. Okay. You can see that here. It's 9 4 1 0 1 4 9 on both tables. So the x values are what changed. The x values each decreased by 2. So this is the parent function, okay? This is the transformed function. This is the parent function. So we subtracted 2 from each to get there, okay? So if we subtract 2, that means we're going to have f of x equal minus 2. Okay, that's how that's going to be set up. This is our k. So if you look at your little chart and you go f of x plus or minus k, that's a vertical translation. That's, nope. I think I'm doing this wrong. Because it didn't move up and down. Oh, see, I am doing it wrong. Because the parenthesis is supposed to be over here. Now, why? Because I know it didn't move up and down. Therefore, it has to be side to side. Oh, which means it's horizontal. I'm just not reading my chart right. Okay. I know it's moving horizontal, so it has to be written like this. Okay. This represents a horizontal shift to the left 2 units, so it can be written either as y equals f of x plus 2, or to get specific to this graph, it's y equals x plus 2 squared, because this original formula is y equals x squared. Man, if I don't screw you up on this lesson, it will be a miracle. But guess what? It's over. We're already at the end. So here's practice question number 1. Interpret the key features of the graph and identify the type of transformation that occurred. What type of transformation occurred from the parent function? So figure this out, come back, and then I'll walk you through it. The first step is always figure out what kind of function it is. This is an absolute value function, which means the parent function is y equals the absolute value of x. All right. So what happened to this? It obviously got moved to the left 4 because it's supposed to touch right here at the origin. So if we're going left 4, normally we would think the number is going to be negative 4. Okay, but it has to be positive because that's if you're doing the formula, which we're not. Don't worry about it. So it is an absolute value function, so it can't be this one because it says quadratic. It can't be this one because it's quadratic. Okay, and did it go vertically? No, it went horizontally. Now these don't go in the same order on yours, so make sure you find the actual right answer. Don't just click number 2. Practice question number 2, the function f of x equals the square root of x was transformed to create the function in the graph. Interpret the key features of the graph. What type of transformation occurred from the parent function? Okay, well, we know, you figure it out and then come back. Okay, we know every parent function touches the origin. So this one got moved right 2 spaces, okay? That means that it's a translation and it's horizontal. So translation can't be reflection, can't be reflection, and it can't be vertical. It's a horizontal translation. Here's practice question number 3. Which equation models the transformation of the graphed function from the original function, f of x equals 2x squared? Okay, so our original function is not the parent function. The original function is x squared times 2. If we look, oh, sorry, you go figure this out. I'm doing bad today. Okay, if we look at our chart from last week, we can see that when we have f of x and the k is right here, like this, then k times f of x is a vertical stretch, okay? So this means everything it's like a rubber band. It got stretched. The sides moved in closer. Okay. So what we need to do is, how did we get from here to here? Okay. Well, this is the slope. So let's make sure our slope's still right. It's rise 2, run 1. So the slope's still good. We're still fine there. But what else changed? It moved up 1. Okay. That is a translation. That's a vertical translation, and vertical translations are written in the form y equals f of x, and the k is outside of the parenthesis. I'm looking at my chart from last week to know this. So it moved up, so it's not a negative. Okay. This is not it, so it has to be that one. Here's practice question number 4. What value of k would create the function y equals f times k of x, f of kx, sorry, on the graph if it was transformed version of the function y f of x equals x plus 2. So this is our original. We're not starting from the parent function. Pause it, figure it out, come back. I had to actually like stop the video and go away and come back after I figured this out. So what we're dealing with is what value of k would create the function k equals f of kx on the graph if it was a transformed version of the function y f of x equals x plus 2. So our parent function is f of x equals x, which is y equals x, which is just a linear function that has a slope of 1 crossing through the origin. So if we go f of x equals x plus 2, then it's still got that 1, 1 slope, rise 1, run 1, but it got moved up 2 spaces, okay? We know that because we can go and look at our chart, and a vertical translation is written like that, okay? So this slope has changed because now we're rising 3 and running 1, so the slope is now 3. Okay, so slope is 3 on this graph. Okay, so what it wants to know is what value of k would create the function that y equals f k of x on the graph if it was a transformed version of this. So we've already done the transformation of moving up. We don't have to worry about the vertical translation. It's already been taken care of here. All right. All we're trying to figure out is this horizontal compression right here. If you go look at your chart, you can see that this formula means it's a horizontal compression. So what that means is, in this formula, what is the value k going to be? Well, that k value is the slope. So k is going to be equal to 3. Here's practice question number 5. The graph of a transformed function is shown. Which option states the parent function and the equation of the transformed function? Pause it, figure it out, come back. Okay, we know that this is a parabola, so it's a quadratic parent. The parent function is a quadratic, which means it has to be y equals x squared. So this first one has to be y equals x squared. So parent function is y equals x squared. Can't be this one. Okay. So it can be either this one or this one. Now it wants to know what is the equation of the transformed function. So if we look at our original, it's the slope. Okay, so the first one is, the first slope between the 2 points is 1. So it's up 1 over 1, which works. And then the next one, the slope is up 1, 2, 3 and over 1. 1, 2, 3 and over 1. Okay, so it hasn't been dilated. It's just been translated because it's been moved up 1. Okay, which means that a vertical translation is written as y equals f of x plus k. Because it's vertical, it went up, it's a plus. Okay, so we should have y equals, the f of x gets replaced by x squared because that's our parent function. Okay, so it should be x squared plus 1. Okay, so it doesn't need these parentheses. That's horizontal, that's side to side. Okay, the only parentheses you would have would be around the x, and we don't need that. So this top one is the correct answer. Here comes the quick check questions. I will not give you the answers, but I will tell you how to figure it out. Interpret the key features of the graph. What type of transformation occurred from the parent function? Okay, so first you need to figure out what the parent function is. Every single one says the same formula, so I'm not cheating to tell you this is a parabola and the parent function is y equals x squared. Okay, what you need to figure out is what happened to it. Is it a vertical stretch? Well, every single one says vertical stretch, so yeah. But how can we tell it's a vertical stretch? Is it because of changes to the x-intercept, changes to the x-coordinates, changes to the y-coordinates, or changes to the y-intercept? If you go and look at your chart from last week, we know it's a vertical stretch, which is a dilation. Okay. It doesn't tell you which one changes, but the formula is y equals k times f of x Okay. So you need to figure out, the easiest way to do this is going to be to look at your parent function for a parabola and see, so like 0, 0 is the same on both charts, and then you have a negative 1, 4 on this transformed one. Go look at the that corresponding point and see if the x values or the y values changed. And that's going to tell you what happened, because obviously if they both share this, then it's not going to be the x-intercept or the y-intercept. Okay. Quick check question number 2. Interpret the key features of the graph to determine the transformation that occurred from its original function y equals the cube root of x. Okay. So what happened to this? Did the graph shift left? Did the graph shift up? Did the graph shift down, or did the graph shift right? So that's your first thing you have to determine. And then do you know that? Why do you know that? Okay. Actually, you don't even need to figure out why. If you can tell whether it went up, down, left, or right, you can just answer that question. You don't have to work any harder than that. Quick check question number 3. Which key features help to clearly illustrate this graph has been moved down 3 units from the parent function y equals x squared? Okay, we know this is y equals x squared. We know it's been moved down 3 units. How do you know? Because of the direction the graph opens, the graph's rate of change, which is the slope, the y-intercept, or the symmetry of the graph. Okay. Quick check question number 4 says create an equation that models the transformation of y equals 2x squared to the function in the graph. So we started with this one. Okay. The parent function is y equals x squared, which you have on your cheat sheet. Okay. It got multiplied by 2, which means that it's a dilation. Okay. And then you have to figure out what else happened to it. It's this little bit on the end. Is it plus or minus 4, and did it get squared? You can do this. Where does the square go? You can do this. I believe in you. Quick check question number 5 says the graph of a transformed function is shown. Determine the parent function and the equation of the transformed function. So the parent function is going to be on your little cheat sheet chart, okay? And then you have to figure out what happened to it and figure out what the next formula is. You don't even have to figure out the formula because it's all the same information all the way through here, except some say minus and some say plus. So if you can figure out there's only one transformation that you need to worry about, and that is the translation. If you can figure out if the translation is a positive or a negative, then you're done. And here is to all the creepy frogs on Canva. This one was one of the very first ones that you could find. And I mean, it's just like, what is going on here? And then this one that's just like sitting there like, hi, I'm going to stab you to death. There's just so much that I'm like, why Canva? Why?